Again, we're going in different segments, and our organizing theme is integrated crop management. And for the afternoon portion, particularly until we get to segment number 8, we're dealing with specific issues: insect management, disease management, and soil fertility and irrigation management. Our next focus will be diseases. And I'd like to call up our fourth panel: Brad Bergerford, Fred Finney, Aidan Weaver, and stepping in for the very ill and very, I won't use the word depressed, but Sally is very disappointed that she couldn't be with us this afternoon. But when she called me this morning, let's just say she sounded very, very ill. And so she, with the flu for the last 4 days. And one of her main concerns was to not share that with anybody. So she made the decision to opt out on this particular panel, but stepping in for her very ably is somebody I've worked with over the years, Melanie Ivy Lewis, who's with Sally Miller, and Melanie can give us a little bit more background on what she's been up to and what she does. And so Melanie will be our pathologist, and Brad Bergerford, Fred Finney, and Aidan Weaver. Diseases. Okay, I think the word has been used like, I don't know, maybe 50 times already today. We've talked about the limits of high tunnel production. We've had farmers saying either directly or indirectly that diseases have been one of the biggest issues in high tunnel growing, and remaining so. And I'll just go out there and say that they're unlikely to go away anytime soon. But certainly the design of a high tunnel system, whether it's fruits, vegetables, or flowers, appears to need to take very much into account what diseases might show up. And Brad, I'll just turn first to you and ask kind of the basic question: what, in your experience, has been consistently the biggest disease issue?
I guess one of the problems we've had, which ties into from the last talk to this one, it's not really a disease, but it's more of a physiological disorder called yellow shoulder disease. I don't know if it's not a disease, but it's more of a disorder of tomatoes. And Dr. David Francis from here on campus has done a lot of work with yellow shoulder, and yellow shoulder can really be disastrous to a high tunnel tomato crop. Yeah, that's working. If you want to know more information about it, it's both fertility related. If you're out of balance on your fertility program, yellow shoulder can rear its ugly head. If you got a certain variety of tomatoes, some varieties are more susceptible to yellow shoulder disorder than others. It can rear its ugly head. So I guess that's one thing to keep in mind. And if you want to know more information, I'm not a disease guy or nothing, but Dave has done a good amount of work on that, and he's got a good website too that'll go over a lot of yellow shoulder disease. But just make sure your fertility program's in balance. If it's potassium's out of whack, that can cause a lot of imbalances within your minor elements, which can lead to yellow shoulder disease. Excessive heat in the greenhouse or even in the field. We've seen yellow shoulder in the field before too under high heat conditions. That's why ventilation, things we talked about today, are important to eliminate that yellow shoulder disease. So if you want more information about that, see me or Matt. We can get you in touch with David Francis's information. He's got the best up-to-date information on that. Other diseases, sclerotinia seems to be a killer, especially where we can't move these tunnels on tomatoes again. Where it gets started, I don't know. Maybe Melanie knows more. I don't know where this darn disease comes in from. It can come in on seed lots and come in on transplants. But once you get sclerotinia started, it's also called timber rot on tomatoes. But these plants will just get a white mold on them. The stem will crack. The plant just starts going down. And the first time I've ever seen sclerotinia was on Freddie's farm about 13 years ago. He called me out into his tunnel. And he had grown, how many years did you have tomatoes in that tunnel at your old farm? 5 years. Never seen the problem. And then on that fourth or fifth years, Freddie had me come out, and sure enough, it was sclerotinia, and then we started seeing it everywhere. If you see a plant that's showing that, you slit the plant open, and the sclerotia, the fruiting bodies of that disease, will be on the inside of that stem. They just look like little mice droppings. That's what they are. They're very hard, and you can't, once you got them in your ground, you can't get rid of them. Now, Raymond Yoder's going to be, I think, is Raymond back up again or not? Raymond's got some good, Ron Becker and Raymond got some, a new, I think it's a biological, isn't it, Ron? That has worked. It worked on Freddie's farm. I'm not that familiar with it, so maybe Melanie or Raymond or somebody can talk about that. But I think those are the biggest problems we've seen, is that yellow shoulder disease and sclerotinia stem rot on tomatoes.
Melanie, we have, you can't see it from where you're sitting, but we have Sally's slide of sclerotinia. And Brad asked, where does it come from? Is this something that's seed-borne? Is it blown in? Where would it originate how would it get to a farm, I guess?
Well, it produces ascospores, which are basically windborne spores that
Push the mic closer and speak louder than what you think you need to.
Can you hear me now?
Oh, yeah.
Okay. It produces spores that are windborne, so if you haven't seen it like you're describing, for several years and then all of a sudden it showed up, probably it came in through windborne dispersal. Once it forms the sclerotia, though, it can stay there for years in the ground, and then the moisture and different environmental conditions can cause those sclerotia to burst open, produce more spores, and then spread again. So it has it has two cycles to the disease: a primary inoculum, which are the spores, and then the secondary, which are the overwintering sclerotia. He mentioned a biological. It's called contans, and it's best. We've worked with it a little bit and seen some good results with it. You should put it on your field or your high tunnel, as soon as you plow down your crop. Basically, what you don't want to do is incorporate those sclerotia deeper into the ground. So you want to be able to have the contans come in contact with the sclerotia, and they basically attack the sclerotia and eat it up. Sclerotia have a thick black coating on them. I don't know if you can see them.
They're not pointed out well, but Brad described them as mouse droppings, and they're here in the stem and stem openings and just above the soil, and we've seen them in soil samples too.
If you crack open a sclerotia, if you just take a lot of pressure or a hammer and break it open, you'll see that it's white inside, and that's the mycelium, or the growing stage, the vegetative stage of the fungus. And so what happens is the contents, is actually a fungus itself, can break open that sclerotium and attack the mycelium and kill it. But the biggest thing when you're using the contans is to make sure that you're not plowing under your crop debris, because then you're incorporating those sclerotia and the contans can't reach it.
Aiden and Fred, how much worry, time, energy, thought do you put into disease management within the tunnels?
Well, yeah, it's definitely a problem. I want to share an observation, though, that I've this morning through all this and some discussions that we had over lunch. If all of you take back one thing today, understand that everybody's growing conditions are different. And I'm the one that brought up the problem about diseases and moving the houses. In this area, and we're right here in Wayne County, I live just 5 miles down the road, and Aiden's 5-6 miles away from me yet. We're in what is classed as a gray area. It is cloudy here 300 days out of the year. Seriously. And Ron Becker just told me the reason they do the mildew trials here at OARDC is this is the mildew capital of the world. So diseases proliferate in this area. And when we're talking about putting shading over tunnel houses, from about this point in Ohio all the way up into Michigan, you don't need the shading. You don't have the sunshine. But from this point on south, you need to think about that because you've got more sunshine. So having said all of that, we have a major disease problem. We had every disease on our vegetable crops this year in this area that's in the book. And Ron Becker is the IPM scout in this area, and he will tell you we usually have a couple major diseases a year. This one he has classed as the banner year at the top of the list. He had seen every disease and every vegetable crop that's in the book. And we don't normally see all of those. So, long answer to your question, Matt, it is a major problem, and that's why we have a chance to rebuild our house this year because we were one that in June, the 60-mile-an-hour wind picked it all up and crumbled it together and dumped it at the end of the row. So after that point, we had a lot of air movement, and we had a lot of outside sunshine, and to his credit, Daniel Yoder, and he's the guy that spoke earlier this morning, he straightened all of our bows for us. So we're going to put the thing back up. We're going to put it on skids, and we're going to be able to move it. So, and Matt and I have debated that subject for a year now. Do you set that thing permanent? And Aiden will tell you, I think he's going to tell you, his is permanent for a couple years at a time. But this is the real expert in this area on tunnel houses. So, Aiden?
Speak up, Aiden.
After that, I don't have much to say.
Well, Aiden,
Well,
but
go ahead, go ahead.
how many disease problems have you had? And you had sclerotinia this year,
Yes, sclerotinia, I have to say, would be the main problem. Then I had some botrytis and some very little early blight. But for the sclerotinia, we think it's very important for ventilation. And on our roll-up curtains, one of the tubings, the screws came out and it lowered it maybe about 6 inches. And we rolled it up, and we didn't think much about it. The other part of the greenhouse was getting air, and so, but there's where the sclerotinia was the worst.
Do you open
So-
up the ends of your house too?
Yes.
You open up the ends and both sides.
When it warms up.
And
yeah.
how high sides do you have? Because I think
4
that's
foot, 4 foot, maybe. Well, the one is 4 foot. The first one was a little bit taller. The sides were a little bit higher, so that was about 54 inches. So we could get horses in to work the soil. That was the reason we had higher. And I really do believe that's a big factor because the first one we built was higher walls, had less.
had less problems.
Less sclerotinia and botrytis also.
That subject came up during the tour. The what some people are seeing are the benefits of higher than 4 foot walls.
Right.
So, are you going to keep going higher, or do you
We're
think the
gonna-
54 is?
We're
going to
go higher.
You're going to go higher.
Yeah, we're gonna go up
Okay.
on the bows, and
Okay.
like we have a board, uprights, vertical, where we have these spring locks attached, and we think with the wind blowing against that board, it'll slow the air movement through the greenhouse, and with the going the flat rate or an angle, we think it'll move more air, and we feel it's very important.
Well, Matt, in this area, we also have some high tunnels that are 6 foot sides.
Okay.
And part of that is because a lot of the folks in this area farm with horses. And 6 foot sides, you can get, and I'm surprised you can get those big horses that you have in a 4 foot side tunnel.
Well, we don't use the biggest horses we got.
okay,
We use
yeah.
those small. But you also know, you got to watch how you drive. It takes an expert to drive so those hands don't punch through the plastic.
Well, this was a special year. I mean, all kidding aside, because it was a pro and con thing, as you know. I mean, if you had material, the price may have been good, but it may have been good because of somebody else's misfortune on the disease side. So, putting aside for the moment that this was just like in Ron's words, the banner year for diseases. Okay, Aiden, Fred, Brad, Melanie, what are the things that you have found to be the most innovative or newly tried or emerging disease management practices in your experience that really interest you as experienced users and pathologists?
I'd say the high tunnel itself is probably the best disease control method we got, because if y'all remember how disease takes place, you have to have a triangle. You got to have temperature, you got to have moisture, and you got to have the host organism. Well, I think Otho pointed out, by just putting that tunnel over top the crops, we can keep that plant canopy pretty dry. And then you go ahead and throw in some horizontal airflow fans, whether they're run by air or whether they're run by electricity, and keep those plants moving a little bit for you get air movement down through the plant canopy. If you keep that plant canopy dry, you've just eliminated one of the points of that disease triangle, which can eliminate a lot of your fungal disease problems. So just getting into the high tunnel itself is a good disease control program, I think.
I agree. It just takes a lot less, chemicals, and we also see just a lot better fruit, better quality, more eye appeal, and when we go to pack, we just wait. I mean, we can't wait. We usually keep those for last to pack. They're just more enjoyable to pack. They're just more quality to that.
Melanie, I heard, this is anecdotal, but I heard of a grower in Indiana who literally, I don't know why exactly, but they excavated the soil underneath their tunnel because they had sclerotinia. They took the soil out and they brought in new soil. I don't know why they just didn't move the tunnel, but they still ended up with sclerotinia, okay, after all that investment. Not to be kind of alarmist or anything, but if somebody gets sclerotinia in the tunnel, is it basically going to be there forever?
It's going to be there for a lot of years, 10, 15 years. Those are just really stable, overwintering survival structures that are being produced, and their goal is to survive. And, I think moving the tunnel or moving the soil is a good approach. I mean, in our high tunnels this year, we wanted to make sure that any plants that you pulled, you picked up the soil around it and took it out so that you're not dropping the sclerotia as you go. But because it has the primary and secondary stages, you run the risk of these spores blowing in, especially if your neighbor has sclerotinia in their fields and they're not managing it properly, then you'll have them producing spores and that blowing into your fields. So.
But, one sec, perhaps you in the audience, kind of like me and the panel, probably sees a connection between the way we started this morning on design and construction and disease. Aiden, you were talking about higher sides, and that might have been driven how you're working the soil, but it's also provided some benefits on the disease side, right?
Right.
Do any of you have questions about design specific for disease management issues?
In terms of composting crop residues, is this going to be helpful for controlling some of these really tough pathogens?
So you'd remove the residue, compost it, and return it.
Right.
Those sclerotia survive composting?
Well, we had significant difference between our compost-treated tomatoes and our non-compost-treated tomatoes this year for sclerotinia, stem rot, or timber rot, however you want to refer to it. So we saw a significant decrease in disease incidence with the compost. It was a dairy compost that was put on it. So, I actually jotted down a note from the fertility little section about the compost. It's valuable for a lot of reasons, for soil fertility management, for water management, and also for disease management.
I don't think you'd want to make your tomato compost, though, out of sclerotinia-infested plants.
No,
No.
That's not what you're
I was asking, would a high-temperature composting be
Kill the sclerotinia.
useful for recycling crop residues in this?
No.
No.
No, sorry, I misunderstood. You want to get rid of that tomato debris, so it provides a food source for the sclerotinia.
So just, if you burn it, can it spread?
Okay.
If you burn residue, can it spread?
No.
No.
No, if you burn residue, it won't kill the sclerotia.
It will not. So Melanie, I'll just pick up on what you mentioned. These sclerotia, these things are meant to go to outer space, okay? Survive, okay? So the normal environmental conditions that we could put them under, composting, burning, drying, they've seen it all. They just kind of laugh at you and just sit there and wait for the the right conditions to germinate. I don't know if that's the proper word.
Yes.
Okay. And then come back to life. So I think what I'm hearing, and I'll defer to Melanie, is if you've got sclerotinia and the sclerotia are there, you can pretty much assume that you may be seeding your soil with them, but the way to minimize that is to get the residue out and away from your planting area.
Yeah,
Am
and
I
someone
right?
someone just asked me to bring up sanitation. So basically in those high tunnels for almost all diseases, you want to be having a good sanitation regime. So you want to be not dumping your rotten fruit or your debris in the tunnel or around the tunnel or in neighbors' fields. You want to make sure that you're clearing it away because that's all source of inoculum. And also when you're controlling sclerotinium, you really have to remember that there's the two inoculum sources. And so if you can knock down the primary inoculum, which is the spores, then you can reduce the chance of secondary inoculum, which are those sclerotia. So in order to knock down the primary ones, you have to do things like not let it come in, control around the area, make sure other growers in the area are controlling for it, sanitation, cleaning out if you're using pruners, that you're disinfecting them. All the typical things that you hear for greenhouse sanitation apply to the high tunnels.
So something that's windborne, we'll use late blight the same way. I mean, these are public health issues, if I could use that term. I mean, it may be fine what you're doing on your farm, but if not to point fingers, but this is an issue where the grower community takes a look at how it does things and says, well, if we can control what's happening on a larger scale, each person benefits. Am I right?
Yes, absolutely.
So with the movement of plants, soil, equipment, you name it, if everyone's attentive to the issues, it benefits each individual. So even though no person is an island, this is a case where no person's an island. They can do great things on the farm, but if what's happening around them isn't up to snuff, it'll come in anyway.
I think that's the same thing on bacterial diseases. We heard David this morning, in his big hay grove tunnel, basically lost his crop last year to bacterial canker, and that leads back to the seed company. Make sure you got good, clean source of seed. Sally Miller has a good fact sheet on treating your seed to eliminate the bacterial diseases. Make sure if you're not growing your own transplants, that the greenhouse you're using is using clean trays, because they can infest those transplants with bacterial canker or any bacterial disease, and you don't even know it. And then if you do get bacterial canker like David did, or even in a field situation, sanitize those fields and get rid of the debris, because it'll blow to the neighbor's farm.
Right. There was a question in the back, I think. Yeah, go ahead, Daniel. Does temperature influence the development of sclerotia?
Well, the sclerotia, I guess I'm not sure exactly what you're asking, so I'll answer this two ways. The sclerotia begin to form and are produced as the plant debris is dying off and there isn't tissue available for the pathogen to live. Then once you have the sclerotia in the ground in the spring, you need moisture, and that moisture creates a pressure buildup inside that sclerotia, which causes it to burst or germinate and then start to produce the primary inoculum, the spores. So yes, moisture does play a role in those germinating, not necessarily in those sclerotia forming, but in them germinating, if that answers the question.
Another question here?
I know you're talking about tomatoes, but once this stuff is in the ground, does it affect all your other crops that you're,
You had a slide on that, didn't you?
I think so.
Peppers.
I think you want to repeat the question. Does white mold, sclerotinia, affect more than tomatoes?
Absolutely. Almost all dicots are affected by it. So, and a good example is lettuce. So lettuce drop is caused by Sclerotinia minor and Sclerotinia sclerosium. And so if you have the sclerotia in the ground and you come in the next year thinking you're rotating with a completely different type of crop like lettuce, you have the chance of getting, under ideal environmental conditions, getting lettuce drop occurring. It also can go to soybeans, it can go to peppers. I don't know of any monocrop, but
Otho showed that nice picture of petunias. We've seen it real bad in petunias as well. So if that's been in the greenhouse or in the area, you can get sclerotia in that.
Well, no, go ahead.
Regarding cleanup, especially on something like tomatoes, I pull out all my tomato vines, but I don't get every fruit that's dropped off, and I also don't get the leaves that have fallen a month and a half, 2 months earlier. Is it worth pulling off the vines if you still have some fruit or leaves that have dropped a month or two ago that there's no way you can even notice that they're there, especially if you're using a compost top dressing to
Yeah.
maintain moisture?
Absolutely. The more debris you have, the higher probability you have of that pathogen feeding on it. So if you only can do your best to get rid of what you can, but yeah, it's going to help. You want to get rid of that. One thing I want to say about the diseases in the high tunnel is that they are such a challenge for us because they are very atypical in their appearance. So something that you might think looks like early blight, you bring in, and it's actually, bacterial speck or spot. And, so all the symptoms are very atypical. So if you are really not sure what you have, you should get it diagnosed so that you can then treat it properly, because they are extremely atypical. And I remember that when I started, 8 years ago, that they would bring this in, and I'm like, oh yeah, that's early blight. And then we would look for bacterial streaming, and it would be loaded, and it's like, oops, so you have to, the symptoms are atypical for sure in high tunnels, and you really need to, if you don't know it, get it diagnosed so you can treat it properly.
At this point, I'm going to call your attention, in case you have not seen it, there are several documents in your information packet that are disease-related. One is a copy of the slides provided by Sally Miller in color, labeled with what disease they are, and lettuce and tomato and other crops. Another is a 4-page fact sheet from Rutgers University, written, I might add, by an OSU grad, but anyway, from Rutgers. Another is an article that Sally wrote that appeared in VegNet this past summer. So there are some resources in the information packet on disease management and identification in high tunnel specifically. But as Melanie pointed out, I think very appropriately, it's beyond my experience, obviously, but we can't look at the same symptom and assume it's what it is if it came from a high tunnel, because it may show up differently, is what you're saying.
Right.
Aidan, what do you make of all this in terms of, I've heard people removing trash from the tunnels to remove the debris and reduce the risk. We've heard comments today about needing to improve the soil quality, partly by adding organic matter and presumably some plant waste to the soil. Again, from a disease management standpoint, are there some practices that you simply won't go without when it comes to protecting against disease development in your tunnels?
Yeah, well, let's say we start in the fall. First of all, we'll remove all the plants. And then we're thinking about maybe planting some rye this year, just for practice. And I heard something about that mustard, which kind of caught my eye a little bit, or brain, or whatever. And we might practice that a little bit too, because I think it's really important. Over the years, what I've experienced is organic matter, in related to disease depression. And I think the higher the organic matter is, the better production you'll have, and the better disease decrease.
Now, am I correct in saying it's not any organic matter? Because what I heard you say is you will take the crop debris out, but you'd want to add other organic matter back in, right?
Like
So that would be your rye, your mustard.
Right.
Okay.
Then also we have some mulch that I got, from a farmer a couple miles from me that I put in, and I think in fertility we seen a difference in that.
Fred, anything from your standpoint that these in terms of practices that you simply won't go without, or that that others won't go without in terms of protecting against diseases?
Well, one thing we're going to add next year is more air movement. And since we have electricity, we do have some big fans, and we're just going to One thing that I noticed is we did have condensation in our high tunnel. Didn't matter what time we opened it up, but we still have condensation, so you still have some moisture in there. We do use, like Brad said, we go down through with the leaf blower for pollination, but I think it's going to be necessary. And Aaron Weaver didn't mention it when he was up this morning, but he's got fans in his high tunnel, which is a heated high tunnel, that are constant. His plants are moving all the time, and he said there's more even heat distribution and there's less disease problems, and I think air movement is really critical. We're gonna, we roll up the sides, we open the ends, but we still, on a calm day, there's no air movement in there, so we're going to add some air movement, which I think is going to be a big benefit.
Go ahead, Susan.
So the fungus infests the plants, and you have to remove those diseased plants. But then if you can't burn them and you can't compost them and put them back on other plants, so what do you do with it?
What do you do with that plant debris?
No, you can burn the plant debris that you move out, but it won't kill the sclerotia that are already in the ground. So you could take it out, you could burn it, or you could till it under somewhere else where that is not going to have crops grown. So you can still let it die off that way, but you just don't want to burn it in hopes that you're going to be killing off sclerotia. That's all.
So can we use that ash or no?
Can you use the ash from that burning process?
I have no idea.
Good question. We've caught it on audio tape, too. That's quite all right. Look, the number of times I've done
But to think about that, Matt, if you're just burning a few diseased plants, even if it's 100 of them, why would you even take a chance on it? Just throw it in the dumpster and let them take it to the landfill.
Right.
Or throw the plants in there and let them get rid of them.
Fred, did you want to say something?
Yeah, there's a new product on the market, it's called Oxidate.
Oxidate.
Peroxide. And it's labeled for soil drench. And I have in the past used it in the greenhouse. And mix it with water, put it in the drip line and drench the soil. You spray it on your plants, it will kill the fungus on the leaves. And it's the only product on the market that kills on contact. And I wondered if there's any research been done.
On oxidate. Melanie, you want to address the oxidate question?
Not really.
Let's let me preface this. I think there's a mixture of experience with oxidate. Am I correct?
Yeah.
Yes.
Okay.
And our lab does not advocate the use of oxidate. We don't have any replicated data that supports its use. The majority of the phytotoxicity that I saw come into the lab this summer was oxidate, due to oxidate damage. But it is controversial. A lot of people are using it, and a lot of people like it, but we don't recommend it as a disease management strategy in our lab.
Matt, ask Aiden. Aiden uses it.
Aiden, what's up with oxidate?
Well, we use it.
And we didn't recommend it.
No, I didn't call you.
Excellent. No, I mean, go ahead.
I mean, we had good success, and in fact, the first year, that's all I used as a fungicide in the high tunnel. And if you use it regularly, an ounce of prevention is a lot better than a pound of cure. And I didn't have much of a problem. And over the next year, I built another one, and I got busier and busier, and I used it less. And my timing was, I used it every other week instead of a week, and I've seen more of it. So I have a hunch it helps.
Okay, I'm not trying to broker any sort of disagreement, obviously, but what did you want to say? That's all. How many oxidate users do we have in the audience? Okay, how many sufficiently curious to maybe try it? No, you don't have to, okay. Again, I'm not trying to broker any sort of, this isn't a convention on what should we do, what should we do with oxidate. from my perspective as kind of an observer, just one person trying to help design systems at work, what I appreciate, and I know what the farmers appreciate, is something what I think you just said, Aiden, and that is used properly. Now, it's possible that for some people, when they use it properly, according to label and so on and so forth, they get a benefit. It's also possible that they use it properly and there is no, quote, statistical benefit, but without a controlled test, they wouldn't have known what it would have been without it, right? Because chances are you may be treating the whole crop, so you don't know what it would have been without it. That's where somebody like Sally and Melanie and other folks come in to test it with and without. And testing in 1 year and then testing in another year is not the kind of test we're talking about. It's side-by-side comparisons. Now again, the comment's not made to say, okay, this is the final answer. But in issues like oxidate, and I know there are other chemicals that fall into the same category, they're controversial because there's so much mixed experience with them. And for those that have success with them, perhaps the best thing to do is continue to use them. For those that are curious, try them. Am I being fair?
Yeah, absolutely. One thing about oxidate is it's a surface disinfectant, so it's only going to work, if it does work, on non-systemic or local pathogens, because it's a surface disinfectant. Whatever's on the surface of the leaf, it'll kill, but it won't move from there. The second thing is because it's a surface disinfectant, it kills everything. So if you're using an organic production system and you're wanting favorable microbes present, you're taking away those favorable microbes by putting oxidate on your plants or in your soil.
So, again, let's just continue that discussion if we could for a second. The reason why it may work for some folks is that their whole disease management program is in good order, right? They're buying clean seed, they mind their P's and Q's, and all of what they do with respect to disease management, and oxidate is another brick in that program, right?
Yes.
But for other people who may not have all the P's and Q's, all the bases covered, it may not be enough. And so, again, the jury is still out, but there certainly have been success stories and others where it's ambivalent, where the outcome was ambivalent.